Hello, my name is Dylan Glover. I'm the engineering and robotics teacher over at the Cabot High School. The Stripe program was a great opportunity for me. I learned a lot. I was able to apply what I learned within the company I was assigned with and the individuals I worked within the Stripe program. I was able to take all this that I learned from all those different things and apply it in my classroom, which benefited my students immensely. The students were able to see the perspective of real world examples and to learn how an engineer actually goes through the process of designing a solution to a problem. And they were able to do a whole lot with this lesson, which I'll get to here in a little bit. I was assigned to to L'Oreal, where I worked within the training department with Stacy Grubel and her team. Within her team, I was helping create a training module that would allow people that come in to the job new or even for relearning, retraining, to go through the training modules to learn what they're supposed to do in that certain process. In this case, I was assigned bulk waste. What bulk waste is basically after each line with the cosmetic that they're working with, when they're switching from one cosmetic to another or another line or another, they would go through the bulk waste process to figure out how much that bulk waste they have. And that determines how much loss they have on that line. When that we found through the system that it wasn't as accurate as they hoped, so we went through observation of various lines, through talking with the people on the lines, whatever it may be. We come up with a solution that would hopefully benefit the lines and help make it more streamlined. And basically, we left it up for the discussion of the department leads and the higher ups. Outside of that, I went through a lot of the different safety procedures of what they do at each line, how they go through making the products themselves. We also were able to observe the various people that work on the lines, from all the way from the line workers, the leads, the engineers, the mechanics. We also followed a MA, which basically is the person that runs the line. If it's a very automated line, it's probably just one person on the line, maybe two. Some lines have more. It just depends on the line. Once I was done with all that, I also went into the Fab Lab because that related to a lot of what I do in my engineering class. And they have a pretty cool setup there where basically they go through the lines and they create their own products. So, like the little pucks that bring the cosmetics around on the line, they learned if they can just make them themselves, they save a lot of money by versus just buying them outright. So they have a whole setup where they can create those pucks themselves and make adjustments wherever needed. Within my lesson, the students did a STEM career interest survey right at the beginning to determine their interest in STEM. We'll talk about the data here in a little bit. We also did a pre-test at the beginning, and we did a post-test at the beginning or at the end. After that, we also did documentation of what's called the engineering design process, which is a process similar to the scientific method. The only major difference is basically no matter where we go in the steps, we can always go back and kind of reiterate or redo certain parts to come up with our final solution. Overall, the kids come up with their idea through research and decided they have a pneumatic base to go with, a cardboard claw, and they're supposed to make that claw better to be able to grip the 5 different cosmetic bottle containers that we had and move them from one location to the other. Throughout that, they did some research. They generated concepts, as you can see right here in the middle. Once they generated their concepts, then they did a decision matrix based on graded criteria that we came up with as a class, and whichever one had the highest grade, that's the idea they went with first. And then after that, they developed that solution based on the decision matrix, and then did testing. And then over on the far right, you see their final prototype. And if that prototype worked, great. If not, then we went back to the process again to come up with a different solution. Here's the various images of the students doing Fusion 360 to CAD their models, kids building the pneumatics or adding their claw systems, the sketches they would do, the annotated sketches, 3D models, the prototype idea. This one was cut out of wood, and then the original model itself right here. Based on our data, I was not surprised on the pre and post test for the STEM survey because all my students choose to be in that class. They're interested in STEM. They're all aspiring engineers or someone in the medical field or whatever it may be. So the numbers were pretty where I thought they would be. We did have a slight increase from beginning to end. But when it came to the pre-post test of the engineering design process pre and post test. We had an average of 59.4% students understanding or had passing rate. After the lesson, we had a 80.15 pass rate, which is a 20.75% increase, which I feel like is a good class average. And I felt like we learned what we needed to learn. When it was all said and done, the students had enjoyed the lesson. They had a lot of fun. They enjoy learning how to apply the engineering design process in a real world example. They enjoyed learning pneumatics. They also found that the lesson was hard, but not too hard. We did talk through how to make it more difficult. One thing we were looking at is maybe doing a entire lesson on just pneumatic systems and creating our own pneumatic systems, so they have some knowledge in that, more knowledge in that versus using a pre-made one, to where they can apply it to this lesson differently. Also, instead of a cardboard model like you see here in the bottom right corner, we're going to create our own 3D model so they can be reused and it doesn't get wet or soggy and break down easier. Cardboard is great because it's free, cheap, everybody can get it, but in the end it was still a struggle for us. But overall, the kids enjoyed it, and I think the lesson was a success. Thank you.